Hello everyone, welcome to Mayur Programming Club. Today we will be solving another daily lead code problem, and the problem's name is hands of hand of states. Okay, so the problem statement goes like this. Alice has some number of cards and she wants to rearrange the cards into groups. Okay, and so that each is of group size, which will be a value that it will be given to you and consist of group size consecutive cards. Okay, so size of each group is fixed, which is group size, and all the cards in the group should be consecutive. So if the first card in the group is 2 and the group size is 3, so the next cards should be 3 and 4. Okay, in total 3 cards and all the cards are consecutive cards. Okay, so till now I hope it's clear. And then further it mentions that given an integer array hand, you have to where each value in this array is the integer that is written on the ith card, and you will also be given an integer group size which represent the size to, of each group in your groups of cards, and you have to return true if it is possible to rearrange the cards provided this constraint, that each group is of group size, and all the cards in that group are consecutive cards. So if these constraints are followed in each group, then you will return true, else you will be returning false. Okay, so it means that you cannot rearrange those cards into the groups of group size where all of the cards in each groups are consecutive cards. Okay, so let's take one of these examples. Let's take this one. Okay, yeah, so let's copy the example. So this is the example that is given to us. First of all, we what we will be doing is we will try to run a brute force approach. The very first approach that can be very intuitive is from the very from each card you will try to think of starting a group. Okay, so let's say I think that one is the starting card of some group. Okay, so what will be the subsequent cards? So it is dependent on the group size. So group size is given to be 3. So other cards should be 2 and 3. Okay, if I am taking one as some starting card of a group. Okay, so what you will be doing is for each of these cards given in the hands array. Okay, you will be thinking of each card as the starting card in some group, and then you will try to form the groups following the constraint that each group is should be of group size, and all the cards in that particular group should be consecutive. Okay, if these two constraints are satisfied by every group, then we can say that okay, all the you know uh, cards can be rearranged by following these constraints. Okay, so you can try a brute force way and try to consider every card as a starting card of each group, and then try to figure out how you can, if you can rearrange it at all. Okay, but uh, since we have to, you know, keep in mind the input size also. If we check the constraints, then the size of the array is of 10 raised to power 4, and group size will also be at max equal to the array size, which is hands. So if you try something, a solution which is near n square complexity, where n is the size of the hands array, then it will result into 10 raised to power 8 operations, and it will give you TLE. Why so? Because there is a constraint that if the number of operations required by your program, order of number of operations, happens to be reaching close to 10 raised to power 8 operations or more than that, then you may get a TLE and your solution will not be accepted. Okay, so that's why. So this is a kind of a operation limit, ops limit you can say. So we have to somehow optimize this. No, so a quick way to optimize this approach is that instead of checking every card for, you know, starting card for every group, we will eliminate some of the cards. How we will be doing that? First of all, we will be sorting the array. Okay, so it will be a little easier for us if the array will be in sorted order. Why so? For example, if you consider, let's say, one array, 2 1. Now let's say this is the hands array, and let's say the group size is 2. Okay, now let's say somehow you are having a frequency count of every card. So let's say this is a card number or card value, which was 2 and 1, and this side it is their frequencies. So 2 is occurring only once, 1 is occurring only once. Okay, so let's say I consider 2 as the starting card of a group. Okay, then the next card should be 3. But from this, let's say we are having a map, hash map kind of thing, or map kind of thing, frequency map you can say. From this frequency map, I will be able to know that okay, we are not having any 3 value in the, or at least it is either not left or it was not there already. Okay, in the hands array. Okay, so you will right away say that okay, this is not possible. So 2 cannot be a starting value. So that's why you will be returning false directly from here, because all the cards should be consecutive, but since the next consecutive card is not there, if 2 is the starting card, so you will return false. But if let's say have you sorted this array in ascending order, let's say the array would have been sorted in ascending order before checking of any card as the starting card, what we would have done is, first of all we would have picked 1 as the starting card of a group, possible starting card. Then we would have checked for the next value, which is 2, and we would have immediately checked. Okay, for one we have already consumed this card, so we would have reduced its frequency to 0, and then we have checked for the second value card, and we would have immediately known that okay, it is present in our hands array, and we would have then seen that we can form a group which is of size group 2 and having consecutive values, and all the cards value would have been exhausted, so 0 here. So when you have arrived at 2, you would have seen that okay, 2 value card have already been exhausted, so they cannot be used for the starting point of some group. Okay, and in that way you have exited this checking each card as a starting card for each group checks, and you would have returned true. Okay, which is the correct answer, by the way. But if you are not sorting the array, then you will miss some of the test cases. So in order to get all the test cases accepted, uh, we are sorting this for all the scenarios, we can say. Basically thinking of all the scenarios, the it is not mentioned that the hands array will be in sorted order, so we should be firstly making it into sorted order. Okay, so that's why first of all we will be sorting this hands array, and then we will be doing the check. So in order to explain you in a better way and make the explanation video a little shorter, I will take the implementation code which is having the same approaches that I have just described, and use it to explain the approach more in depth. Okay, so let's take a fresh slide and paste the implementation code and get rid of this toolbar for now, and let's zoom in a little bit. I think this should be visible enough. Okay, so let's try to make sense what we are doing here. First of all, there might be a test case, for example this, or there might be a scenario where you will be not able to form all the groups of group size. Okay, so the very so all both of the two conditions should be satisfied, that all the groups should be of group size, and all the cards should be of uh, consecutive values. Okay, so for example, if we take this as our input 1 2 3 4 5, and group size is of size 4. Okay, then let's say I make a group size of 4. After that I am left with a group size of 1, but we were mentioned that each group should be of group size. Okay, but it is not the case here. Okay, so that's why we will be returning false. So these are those conditions in which every group will not be of group size. Okay, in that you know uh, scenario you will be returning false. Then you would be wanting to have a frequency map, just like we discussed in the approach, that this kind of frequency map you would be wanting to have in order to check whether we are left with any cards in the what are the cards that we are having in our hands array uh, at any instance. Okay, so it will help us to do those checks in order of one, so we are making a frequency map. So the value will be the card value, and the key will be the card value, and the value will be the frequency of that card. Okay, so card value and key, this will be key, and the value will be frequency. So then we will populate our frequency map. Okay, once we are done with it, I have already discussed that why we will be sorting the array, because of the scenarios like this case where the input hands array was sorted in descending order, you can say, and group size was 2. So in order to correctly answer the this kind of scenarios, you will be sorting the array. Okay, so once the array is sorted, then what you will be doing is, first of all, for every card you will check whether this card can be a starting card for the current group or any group. Okay, for each card in hands array, You will check if this card can be a starting card of the current group. Okay, so if there is a situation that the current card's value is already used up in some other group, so you cannot use this card as the starting card of the current group. In that condition you will continue. For example, let's say we have already formed this group. Okay, this group have already been formed, and all the cards that were in the hands array, which were used to form this group, are already exhausted. And while traversing the hands array, you came at this point and you are tried to access the card 2 for the starting card of current group. But by this frequency map you will come to know that okay, you have already exhausted 2, there are no frequency left for 2, or it is having 0 frequency. Then you will continue to the next card. Okay, and this thing will continue. And proceeding further, if it is not the case that the current card value is not entirely exhausted, then you can consider it as the starting card of the current group. Okay, so in that case you will go with this loop. This loop is nothing but we are generating the subsequent card values. Okay, from the current card value to group size minus 1. Okay, current card value, and we are making increments of one card value at a time. Okay, and if at a certain point you arrive at a certain condition that the current card value that you are exploring is already exhausted in the hands array, then you will know for, or it was not there in the hands array at all, then you will know that okay, we will not be able to rearrange all the cards provided the given constraints that each group should be of size group size. And the second one is that all the cards in each of the groups should be consecutive. So the second condition will be violated in this case and you will be returning false. Okay, so and proceeding further, if this is not the case, then you will consume the one frequency of this card's value. Okay, so for example, here you can see that if you sort this array, it will be 1, then 2, and then 2, and then 3, and then 3, then 4, then 6, 7, and 8. Okay, so if let's say you have consumed, and the frequency map would be something like 2 is having 2 frequencies, so you have consumed uh, one of the 2 frequencies in the group 1 2 3, then you will reduce its frequency by 1. Okay, this is what we are doing here. So and then once you have exited this particular check, okay, so this was the first condition check that we did here, whether we will be able to form all the groups of size group size. And this is the second check that we did, that all the cards in every group should be consecutive. Okay, so once these two checks are done, then we can say that okay, for sure we can rearrange all the cards provided the two constraints that we have to follow. That first constraint is that each group should be of size group size. Okay, each group size should be group size, and every card should be in every group, all the cards should be of consecutive values. Okay, so then we will be returning true. That is all. And time complexity wise, because we have used sorting here, and let's say the size of the hands array is n, then it will be order of n log n. Okay, and you might be thinking, or that we have done a wrong evaluation, that this thing will be executed more than n number of times. But this check that we are making here, and there will be some values if the conditions are being violated, that you will be returning false in middle of the calculation. So it will be close to order of n. Okay. uh, Rather than being close to order of n into group size. Okay, so it will be order of n, you can say close to order of n. So that is why the overall time complexity will be n log n. And as far as the space complexity is being concerned, then it can be order of n. Basically every value in the hands array would be unique in that case. For example, 1 2 3 4 5 6 7 8 9, so all of these frequencies would be appearing at least once in the frequency map. So in that case you will be having a phase complexity of order of n. Okay, so these will be the complexities and this will be the approach. Just giving you a quick overview what we have done here. First of all, we have checked the first condition, that every group should be of group size. Then once we are past this, once we have passed that condition, then we are checking for the second condition, that in every group each all of the cards should be of consecutive values. So for that, what we will be doing is, for each card we will are checking this card's possibility to be the starting card of the current group. Okay, for that we have applied two ways. First of all, we have used the frequency map in order to check for the cards in the hands array as of now at any instance in order of one time complexity. For that we have used this frequency map. And sorting we have used to take care of the scenarios like the hands array is 2 1 and group size is 2. Okay, so after sorting it will be 1 2, and which will give us the correct result. Okay, so that's why we have used sorting. And other than that, it's just a simple checking for every consecutive values in every possible group. Okay, so I hope this solution walkthrough added some value to your DSA journey of honing your DSA skills. And if you are still having any doubts or any queries in general, then you may ask them in the comment section. I will see you in the next video. Till then, keep solving problems and keep practicing. Thank you for watching.